So here's an example problem for specific heat. The problem reads, to what temperature will 50-gram piece of glass raise if it absorbs 5,275 joules of heat and its heat capacity is 0.5 joules per gram degree Celsius. The initial temperature of the glass is 20 degrees Celsius. So the first step we want to do is identify our given information. We know the mass of the object is 50 grams. We do not need to convert this because if we look at our unit for specific heat, it has grams in it, so we can leave it as grams. We know that the heat added, which is Q, is 5,275 joules. We also know that the specific heat, which is capital C, is 0.5 joules divided by gram degrees Celsius. And we know the initial temperature is 20 degrees Celsius. We are looking for the final temperature. So our formula reads that Q equals mc delta T. But the thing that you need to remember is that delta T is the final temperature minus the initial temperature. And now we have our final temperature that we are looking for in our formula, so we can plug in our numbers. 5,275 joules of heat is applied to 50 grams of a substance that has a specific heat of 0.5. And we're looking for the final temperature, and we know the initial temperature was 20 degrees. So now we can simplify. 5,275 is equal to 50 times 0.5, which is 25, times T minus 20. There's two different approaches you could take at this point. You could distribute the 25 inside the parentheses and then solve, or you could leave it like this, and since 25 is being multiplied by our unknown, you could divide by 25, which is what I'm going to do. So then we take 5,275 divided by 25, and we get 211. So now 211 is equal to my final temperature minus 20. And then to get the T final by itself, because this is a negative 20, I'm going to add 20 to both sides. So my final temperature is equal to 231 degrees Celsius.